So option 1, logs on opposite sides. Logs on opposite sides you can drop. Option 2, 1 log you can loop swoop. They're on the same side. Moving that logarithm over there, I'd still have it weird. That doesn't work. I'm look at that and I'm like, I don't know what to do with that. So condense first and then determine. Get it to where you've got 1 logarithm on one side and 1 logarithm on the other side, if there is one, and see which option it is, option 1 or option 2. So how do we condense when we see subtraction? I want to remind you that when you subtract, it's division. That's supposed to be a little bitty divide. That is too teeny tiny. I think I just made that worse. Yeah, that's awful. All right, to subtract is to divide. So if I condense this into 1 logarithm, it's the left one divided by the right one. The one that has the minus is the one that goes in the bottom. So we have log base 10 again. It's implied to be there. So 10 to the second equals x over 4. 10 to the second equals x over 4. Well, 10 to the second is 100. And to get x by itself, I would need to multiply by 4 on both sides. So x equals 400. Is it large? Yes, it is. Is it wrong? Nope, it's not. Let's prove it. If x is 400, that should make sense. So if x is 400, that's supposed to make sense. Let's see what happens. That's not 396. That is 400 divided by 4. 400 divided by 4 is 100. The implied 10 is right there for the base. Is 10 to the second 100? Yes, it is. 400 works. Not much left. Option 1 or option 2? Well, clearly we haven't had another option 1 because they're just so basic and so easy. So let's practice some more option 2s where you gotta condense and then loop swoop. We change it from bay to bia. So let's get 1 logarithm together. Log base 2, I see subtraction, which means division. So x plus 3 is on the top, x is on the bottom. Okay. We have 1 logarithm, that's option number 2. We're going to convert using loop swoop. From log is bay to exponential is bia. 2 to the second equals all that business right there. 2 to the second equals x plus 3 over x. Believe it or not, you have the skills to handle that. If I'm trying to get x by itself and x is in the denominator, my first step is going to be getting that sucker out of there. So I'm going to multiply by x on both sides. So 4x on the left equals x plus 3. I'm sorry, it's getting really late. That's going to bug me. Go slower. 4x equals x plus 3. I will need to get my x's together. So 3x equals 3. And clearly, x equals 1. That's a 3. X equals 1. Let's check it. Log base 2 of 1 plus 3 minus log base 2 of 1 is supposed to equal 2. Well, clearly that's a 4. When I condense those to 1 logarithm, I have log base 2 of 4 over 1 is supposed to equal 2. So is, in fact, log base 2 of 4 equal to 2? Well, is 2 to the second equal to 4? Yes, it is. 1 is our winner. Okay, I'm hoping you're starting to catch on. Condense. When you see subtraction, it means division. Negative 4x goes in the top, 3 goes in the bottom. Loop swoop, converting from bay to bia, from logarithmic to exponential form. 6 to the second equals negative 4x over 3. So 36 equals negative 4x over 3. That's a positive 3. We're going to multiply by 3. 90 and 18, 108 equals negative 4x. Divide by negative 4. I believe that is 27. 80 and 28. Yeah, good. Negative 27. So x equals negative 27. Now, very often when you get a negative, a lot of times it's going to be extraneous. That's not the case this time. This is when a negative is totally fine. Check it and watch what happens. I'm going to need some extra space for this. So I'm going to check this one. Log base 6 of negative 4 times negative 27 minus log base 6 of 3 is supposed to equal 2. A negative times a negative is a positive, so we don't have an issue. What I do need to make sure you understand is why, if that is a negative, you would have an issue. See, you can't take the logarithm, no matter what the base is, of a negative number. That can't be a negative. Do you remember what the parent function looks like? Where you have the vertical asymptote, and then shoot, there it goes. There are no negatives, at least not for the parent. You can shift it and make it go over there, but you still can't take the log of a negative number. So when you have log base 6 of 108, it could have been a negative if that was a positive 4, and then you would have had a problem. It wouldn't have worked, it would have been extraneous. But because the negative times the negative turns that into a positive, we have no issue. When you put those together, log base 6 of 108 divided by 3, 108 divided by 3 is 36. So you have log base 6 of 36 equals 2. Is 6 to the second equal to 36 when you change it from bay to bia? Yes, it is. Negative 27 is not extraneous. It works just fine. Okay, last one, looks like. Yeah, sweet. All right, last one. Let's condense. Log base 2, you see a plus sign. That means you're going to multiply. So we have 16x, and that equals 8. That's not a grade 8. Okay, fine. Log base 2 of 16x equals 8. So 2 to the 8th equals 16x, excuse me. 2 to the 8th equals 16x. Well, 2 to the 8th, if memory serves me correctly, is 256. I should have checked that before I started making this video because I can't remember exactly. Let's see, that would be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is, yep, I'm right, 256. So, I don't know why I just put an 18 there as well. Nope, that's a 16. So 2 to the 8th is 256. We're going to divide by 16. Coincidentally, 256 divided by 16 is 16. All right, let's check it. I'm going to need some space when I do this one as well. I'll make it go down in a minute. log base 2 of 4 times 16 plus log base 2 of 4 equals 8. So log base 2 of 64, it's 4 times 16, plus log base 2 of 4 can condense through multiplication. 64 times 4, take a guess. 64 times 4 just happens to be 256. And 2 to the 8th is 56. So 16 totally works. Next time in 12.6, we're going to do some more difficult ones. Once these get good, once you get comfortable, we need to make sure you handle what's extraneous and what's not extraneous. So that's coming in lesson 2.6. See you then.